was a time when the best companies couldn't even consider robots for their production lines. But in today's complex world, the challenges of advanced technology, compounded by competitive world markets, have made robotics a virtual necessity for competitive electronics production. As a world leader in high-performance robot and vision systems, Adept Technology has gained a unique perspective on the use of flexible automation throughout the electronics industry. In this videotape, we'd like to share a first-hand look at how today's leading electronics firms are using today's most advanced robotic systems. Around the world, makers of high-tech electronic products are being challenged to improve quality, increase flexibility, and boost the bottom-line effectiveness of their manufacturing operations. For a growing number of firms, including world leaders in the computer, defense, and telecommunication industries, Adept Technology's flexible robot and vision systems are helping meet this manufacturing challenge. We invite you to join us as we tour state-of-the-art robotic production facilities at Control Data Corporation, Digital Equipment Corporation, and the Xerox Corporation. At Control Data Corporation's Computer Systems Manufacturing Division, just outside Toronto, Canada, this vision-assisted robotic workstation assembles surface-mount circuit boards for CDC's high-end mainframe computers. Designed and built by Gelser Systems Company of Westerville, Ohio, this robotic solution offers greater flexibility than dedicated equipment and provides higher, more consistent quality than manual production techniques. While the robot arm is the most obvious part of the workstation, the system is actually a network of hardware and communications channels driven by custom software, run on the powerful Adept controller. This multitasking controller coordinates part feeders and automatic tool changing to allow the robot to locate and acquire over 128 electrically unique surface mount components. To determine which components are needed for a given board design, a CAD-generated database is downloaded to the robot controller. Placement locations for individual components are given relative to fiducial marks on the board artwork. Once these are sighted, the system automatically calculates precise coordinates for hundreds of placement locations. Using this capability, production may be quickly changed from one board type to another without reprogramming or mechanical adjustment. During assembly, an Adept Vision system uses a total of 4 cameras to guide the robot through acquisition, inspection, and placement of over 20 different component types, ranging from very small discretes to the fine-pitch 172-lead quad pack. For this component, fine tolerances dictate an additional visual check of the placement location. Inspection of quad pack leads ensures part integrity while indicating alignment relative to the robot arm. Using this information, the final result for CDC is component placement accuracy within 0.003 of an inch. As surface mount technology spreads throughout the electronics industry, this kind of consistent quality, combined with unprecedented production flexibility, is only one reason innovative firms are choosing Adept solutions for their manufacturing operations. The experience at Digital Equipment Corporation's Springfield, Massachusetts facility shows how robotic solutions can also work within a larger manufacturing system to achieve even broader competitive goals.
We wanted a manufacturing system that would allow us to make our low-end tape and disc drive products more competitive in the world markets that we serve. More competitive in terms of product quality, time to market, and cost. We needed a manufacturing system that allow us to respond to changes in market demand quickly. And we needed a system that would allow us to change our product mix easily.
The solution, developed by Digital's Advanced Manufacturing Technology Group and the Shuttleworth Corporation, is a completely flexible, computer-controlled production facility. Here, an entire family of tape and disc drive products are produced by a system of interchangeable manual and robotic workstations. At the robotic workstation, a barcode reader and a grayscale vision system identify incoming components before they're assembled by a two-robot system. Once the system verifies that all needed parts are available, the assembly process begins. During assembly, the robots use interchangeable end-of-arm tools to perform a wide variety of assembly functions. For instance, one robot uses a special gripper to acquire and position electric motors in the tape drive mechanism, while the other robot uses an automatic screwdriver to complete the assembly operation. Throughout the entire process, the robots are in constant communication with each other to assure efficient, coordinated assembly of 14 total parts. According to Digital, flexible automation has already paid off with the fastest production ramp-up of any storage product in their history. In addition, the Springfield facility has reached a level of quality and production efficiency that makes it competitive on a worldwide basis. As a result of this success, Digital is adding more robots to the Springfield operation and has already chosen Adept solutions for manufacturing applications at other Digital facilities. While the installations of Digital equipment and control data show how robotic solutions contribute to new production systems, the experience at Xerox Corporation shows how Adept robots can also work to improve existing manufacturing operations. Here at Xerox's El Segundo, California facility, millions of printed circuit boards are produced each year for the Xerox line of office products. To maintain its competitive position, plant management must constantly find new ways to achieve world-class quality and production efficiency. Recently, it took advantage of two opportunities to improve manufacturing effectiveness with Adept Robotic solutions.
We've had two systems installed in our facility, a test cell that was installed in April of '86, and that test cell has been an extremely successful system, been in full production, running close to 800 boards per day through it with almost zero problems in the entire cell. The Adept robot has performed beautifully for us. In November of this year, we finished the installation and started production in a 3-robot insertion cell. And since that time, that cell has also performed to a high level of productivity for us.
The first Xerox installation is a robotic test cell designed and built by Chad Industries of Orange, California. The primary role of the workstation is to load and unload finished boards from a computer-controlled test station. Tracking the status of 3 individual testers, the robot loads incoming boards into the first available location. Then, when testing is complete, the robot transfers good boards directly into a shipping container and sends bad boards to an adjacent rework area. In this way, the robot eliminates quality problems caused by post-test handling and provides an economic alternative to manual test techniques. The second installation, also designed by Chad Industries, is a series of 3 robots inserting odd-form components onto partially completed printed circuit assemblies. The first work cell uses a single robot to place connectors and other components with high lead integrity. Parts are acquired from linear and vibratory bowl feeders, and immediately after placement are secured by an integrated lead clinching system. A compliant wrist on the robot's arm confirms a component has been successfully placed. Or when a bent lead or other problem prevents insertion, the robot senses the error, discards the part, and begins the process again. Placement rates for the cell average 12 components per minute and support production of 66 boards per hour, 3 shifts a day if required. Depending on board design, the single cell places up to 14 different component types before sending the board to the dual robot workstation. Here, 2 robots work together to place components that require lead straightening or cutting. The presentation robot works full-time to acquire the components from their feeders and places them in the straightener cutter device. The insertion robot removes the components and places them on the printed circuit assembly with a special gripper that compensates for component body-to-lead inaccuracies. The result of this technique is consistent, high-quality assemblies with better than 99% yield. Both Xerox insertion cells operate using a software package called AIM, developed by Adept to simplify robot implementation and operation. AIM keeps track of feeder locations, component status, and other information required to manage the assembly process.
We purchased the entire robotics system from a systems house, and the systems house modified the AIM software for the features that they added to the cell. And now that we've had that in our shop running, we've also taken the software. We have taught new boards, entered new programs into the system. One of our maintenance operators does that very frequently and finds it very easy to work with and very easy to add new boards and new components to the cell.
Adept Robot and Vision systems are already working hard at control data, digital equipment, Xerox, and other electronic leaders to improve quality, decrease cost, and increase production flexibility. From these installations to applications as diverse as mil-spec tinning, and adhesive dispensing, the bottom line is improved manufacturing competitiveness. Adept Technology, headquartered in San Jose, California, with offices and affiliates across the country and around the world, is ready to help you see how robotic solutions can meet your electronics production challenges.